right, this recording is for 7.3. Now here, equations. Okay, equations, that means we're going to solve. So that means because there's an equation, therefore it's only for some values that would satisfy the equation. Okay, so I'm going to use a blank page to write out the points of this section. All right. Now, first of all, I hate these very ugly writing here, but just bear with me. Hopefully, by some practice, I could get better, but doesn't look like so far. Okay, so now the points of the 7.3. Okay, so now first point is we talk about solve. Now, there's in terms of the type of the question, there are two types. One is rather simple to solve. Now, another one is that it becomes a quadratic equation to solve. Quadratic equation to solve. Now, in this case, it will involve factoring. Okay, that's the first two things for us to realize it. And I will show different examples. Now, the second is that the point is in terms of our solutions, there's also two things to be considered. Now, the first thing is that if the angle or your x, because you're solving for this angle, that is in within the 2 pi, or we're saying nowadays we just say 360 degree and 2 pi slash, so we get used to both the radian and the degree, and also larger than 0 or 0 degree. So that means if in this four quadrants, 1 and 2 and 3 and 4, then you always have two solutions. Why? Because if your signed value is positive, then that is in this, again and again, all students take calculus. So if your signed value is positive, and then you're not only this angle is here, also you would have another angle which is not here, but this angle is right here. So you got another two angles. So this is always two solutions within 2 pi. That should be something that you are fairly aware and already familiar with. There's another thing you must have mentioned in your previous study. Also, you needed to also know how to write it out into so-called a general form. Now, what does general form mean? General form means that if you have any angle that is larger than 360 degrees. Now, for example, if you have an angle here which is 30 degrees, or again, that is a pi over 6, and this angle start turning from here to here, that is your pi over 6. But this angle turn to here and then turn again here. So then your angle now will be 360 degree plus your 30 degree. Or another way to say is your 2 pi now plus pi over 6. However, this can turn again. Then it becomes 2 pi multiplied by 2. This is 2 pi multiplied by 1. Then it's 2 pi multiplied by 2 is a 4 pi now plus this. And that can turn forever because this could be a coterminal angle. So then in this case, the general form means you always, if your solution, your x is a theta, this would be include 2n pi. Many 2 pi added on, which is for sine and cosine. Because sine and cosine, their cycle is by 2 pi. But if for tangent, then as we may know, that is by just pi. And that is for tangent and cotangent, right? So that is our second point. Now we have third point. Now what is the third point in this section? The third point is basically, that's called the different situation. That would be, so let's use the big D, is different situations in seeking solutions. All right. Now, first one, we're saying, okay, well, what does that mean? Well, it means it's okay. How about the first one? The first one, okay, how about it's just a simple way to seek solution, all right? Okay, well, now second way is, okay, well, it doesn't look that simple. Okay, well, then that's called, okay, let's say quadratic is in our way, quadratic. Okay. All right, now the third way is that, okay, well, general form, you said that 2n pi, or 2n, n pi, if sine cosine, always just add on 2n pi. And if it's tangent, cotangent one, I need to write the general form and just add on n pi. Not that simple, because some of the questions, so-called, some of the solutions, you can find the better way, so-called the better way to write the general form. To write the general form. So I'm showing you an example about what that means. And then the last thing is that if when you're you're seeking solutions, you used, the method while seeking solutions, you used called square the both sides. Square the both sides to trying to find your solution. You use both sides, square the both sides. Then you need to check your solutions to see whether or not anything needs to be rejected because it's extraneous root. You need to check your solutions. All right, so these are the points in this section. Now I'm going to also list up the number of the questions that I'm going to demonstrate. I'm just using the example in the textbook. So for this one, the simple one, I'm using example. I used a different color. I use example 2. Okay, so if you needed to relook at the example to figure out what I meant, you can always go to that. Now I use this number 10 to explain. Okay, oh, sorry, I should do this one here. Okay, so this is number 2. I'm going to talk about this point. I'm going to use number 10 to talk about this point. And then I'm going to use number 5 to talk about this point. And the last one, I'm going to use number 4 to talk about this point. All right? Okay, so then let me go back to the chapter 7, the book here. Okay. All right, so number 2. Okay, number 2 is right here. Okay, so this is a very simple question. All right. Now, first of all, your solution need to be in this one, and then you need to also write out the general form. Okay, so now this one, that equals that equals that. That's plus that equals that. Okay, now move your negative cosine to over this way. Move your root of 2 over to the other side. You become 2 cosine x equals that, then cosine x equals to this. Okay. Now, as we said, right from the beginning, if we look at the root of 2, we need to think about pi over 4, right? We need to think about pi over 4. But because also your solution, your value for cosine is negative, that means it only is in the second quadrant and the third quadrant. So this one means your reference angle is this pi over 4. So this is a pi over 4 here. That means your one solution is this angle, which means pi subtract pi over 4, right? And then you have another angle. So this is one angle here. Then you have another angle, which is here. So then this one is pi plus pi over 4. So then this one will be 4, 4, and 3. 3 over 4 pi. This is 4, 4, and 4 add on 1 is 5 over 4 pi. And this is your 2 solutions. As I said, you always have 2 solutions within this 4 quadrants range. Now, after that, writing into general form, okay, well, that's this solution plus 2n pi, another solution plus 2n pi, and n is an integer because n can also go -1, right? And if n is 0, 0 means this 2 here. Now, second one, we're going to use number 10. So then that was showing you needed to use quadratic to solve. So that should not be a problem either. So this is a cosecant square, subtract 2 cotangent. As soon as you see cosecant and you see cotangent, then you should think about that property is that 1 plus cotangent square equals to cosecant square. This property, okay, there's number 7 or number 8. I think it's number 8, or the basic fundamental, the trig identity, okay? So that also means this one, substitute this one using this one, because then you got all cotangent. So that's a cotangent square, subtract that, now 1 add on to -4 become -3. So in this case, to think that most of you don't need to do that, but this cotangent x is just like m. Okay, so that becomes m squared, so m squared, subtract 2m, subtract 3. If this is easier for you to see, well, sure. So that means factor that means m subtract 3, m plus 1 equals to 0. Therefore, m equals to 3, m equals to -1. And then bring the cotangent back here. That also means cotangent x equals to 3, or cotangent x equals to -1, okay? So that also means your tangent, because in your calculator you will not have a cotangent to punch in. So you change that to tangent. So that is tangent is 1/3. Cotangent is -1, but tangent is still -1. And then so you got this, and you got that, and you punch into your calculator, and then you have this for solution. And you have also this for solution, add on pi. Why is add on pi? It is because for your tangent again and again, all students take calculus. So in this region and this region, tangent is positive, right? So because it's a tangent is a positive value, now your first one is this one. That means your reference angle here is this 0.3218, and then of course you have to use a pi to add on to this, and this is your other angle. Now the other one is a -1. So -1, that means your tangent is in this region and is in this region here, right? So in that case, we also know the tangent pi/4 equals to 1. Why? Because this means that you have the x, y/x, right? They both are 1. So then, excuse me. So that's 1. So your theta is pi/4 for your reference number. However, this is -1. So that means even though this is your pi/4, you have to use your angle now. It is here. This is pi/4, but then your angle is over here. So that means you use the pi, subtract pi/4, then that is your 3/4 pi. And also another one is all the way go to here. All the way go to here. So that means 2 pi, because this is again is your pi/4. So this is your 2 pi subtract the pi/4, and that is your 7/4 pi. Okay, so these two solutions should not be that bad. So there is solutions for the first one is this one, this one, this one, and this one. The 4 of them in the 4 quadrants. Now, how about we're writing out in a general form? This is the interesting thing. Because if you note, this is d4 by pi. This is also d4 by pi. That means you're only using this first one, you add it on to an n pi. It's not even a 2 pi. Just add on to the n pi. This number shows up, and then add on to an n pi, this number shows up as well. That is the thing that we need to talk about for so-called the general form, a better way to write. This is the better way to write. Okay, I'm going to use another example to explain. So I said we're going to use number 5 to explain this better way to write business. So number 5, that I would just not do the solution. Okay, so we would just say, okay, we already solved it, and then our solution is this one, and this one, and this one. That is in this 4 quadrant business. Okay, and in this case, of course, we can write 3. This one plus 2n pi. This one plus 2n pi. This one plus 2n pi. This is called acceptable answer. However, if you look carefully, from here to here and from here to here is differ by 2 over 3 pi. So in this case, then that means if you repeat it by 2 over 3 pi, and you just add on the first one, then it's going to repeat forever. So in this one is by repeating 2 over 3 pi, then multiply by how many repeats. So this is so-called a better way to write the general form. Okay, bear with me the last one. Last one, we're using number 4 to resolve. No, I said it wrong. Should not be number 4. This should be reject. Let me take a look. Is that number 4? No, not number 4. Which one did we have to do it? Okay, so it's a number 7 as a matter of fact. Okay, so number 7. So let's take a look at number 7. Number 7 is this. Cosine x plus 1 equal to sine x. So I can, what do I do? Can I change sine x is cosine x plus pi or minus pi? Yeah, well, but that's still a little bit more complicated. So what do we do is that we're going to square both sides. We're going to square both sides because as soon as we square both sides, we get a cosine square. And then we got a sine square. So in this case, we can change the sine square into 1 minus cosine square. This is our beautiful, beautiful strategy to do this type of question. So then therefore, we got the variable is only just the cosine and its quadratic equation. Okay? So now from here, we got 3 solutions. Now each solution needed to be checked because one of them might be just created by this way of seeking solutions. Then in this case, this one is accept, this one accepted, this one is reject. All right? So then in this case, our solution is only this 2, and then we do that. And the reason why we cannot do, okay, well, from here to here, that is also deferred by pi over 2. Now, why don't we just do pi over 2 plus n pi? Well, the reason why you cannot do that is because this pi over 2, because this becomes 1, that becomes this one, but we have to reject this one, right? We have to reject this one. Therefore, you cannot do n pi. It has to be 2n pi. And then the other one has to be included, and also is a pi plus 2n pi. Okay,